Hello and welcome to the walkthrough for my 7 Secure Code Review Challenge. My name is Florian Walter and this challenge is a host header injection. So in this video, first I'd like to go through the source code with you. Then I'd like to show you the vulnerability, how to identify it solely by looking at the source code, and then we'll exploit it. And in the end, we'll remediate the vulnerability. Okay, so let's have a look at the code. So this is a Node.js app, or an Express.js app to be precise. So what do we have here? So we have 3 routes. We have a get profile, which looks like it's just returning a hard-coded JSON. So that's not too interesting for us from a secure code view point of view. Then we have a post register route, which only sends back a string user registration successful, which is also not very interesting to us from a secure code review point of view. These 2 routes are simply because I wanted the app to be a little bit bigger and not just have the vulnerable route in it, right? And finally, we have the post reset password route. And this is a route that I always like to check out whenever I like to assess the security of an app. So what do we have here? So the first line, it initializes a reset link, which looks like it's a link to reset your password, right? So we have a token here, and the link goes to the domain of the host header. And that's very interesting because reg headers host, like all part of the request, is attacker controlled, right? So since the host header or reg headers host is attacker controlled, we need to look what happens with this variable reset link because it's partially under the control of an attacker, right? But before we do that, I would like to address the password reset token here. So this functionality, it's a password reset functionality, right? You forget your password, you trigger a password reset, you provide your email address, and then a link with a unique token is sent to your email address. And if you actually own this email address, you can click on the link and set a new password, right? So that's how password reset flow works, right? And obviously for this, the token needs to be a cryptographically secure random string, right? Which generated token 123 obviously isn't. But in this challenge, I'd like to focus on host header and ignore the token for now. But this would obviously be a very bad vulnerability that allows me to reset anyone's password if I know that it's generated token 123. So now that that's out of the way, let's see what happens with the reset link variable. And we can see here we have this transporter send email, and that takes in a from, a to, a subject, and a text, right? So that looks like it's sending an email. And what kind of email? Okay, from support@example.com to the provided email address, and the subject is a password reset, and the text is click here to reset your password. So that looks like a normal password reset email, right? And if you look at the transporter, which would be the next thing we would do now, we can see that it's just a mocked transporter, right? But as we can see here, we should imagine this to be a proper email transporter that actually sends out an email, a password reset email. Okay, so what does that mean? So we have an API, there's a password reset functionality. It sends an email with a password reset link, and the domain of the password reset link is under attacker control. Okay, so now let's talk about the exploitation. So before we exploit this, I want to show you how to use the password reset functionality as intended. And this time we're not going to use Burp Suite, we are going to use curl. So let's get out my terminal. And as you can see here, this part is running the app via Docker Compose. So in this panel, we will be able to see the logs. And down here, we'll be doing the requests. So let's send a post request to reset password that resets the password for test@example.com. So this is the request. So we send it to our reset password link, and we reset the password for test@example.com. And this will send the password reset link. Click here to reset your password, HTTP localhost 3000, which is our API, right? And then the reset password with the hard-coded token, and if the user clicks on that link, they'll be able to set a new password. So far, so good. So that's all working as intended. And now let's do something else. Now let's send a post request to the same reset password link. But now as the host header, we provide dubflow.com, and the email address is now victim@example.com. And let's see what this does. So this now sends an email, a password reset email to victim@example.com, which makes sense, right? And now the text of this email is click here to reset your password, http dubflow.com reset password with the token, with the generated token 123, which allows you to reset the password of the victim example.com, right? And that's very interesting, right? Because this is all of a sudden dubflow.com and no longer localhost 3000. And this is because of the host header injection vulnerability. So what does that mean? That means that if the victim user now logs into the email address and looks at this password reset email and clicks on the link, then all of a sudden a request will be sent to dubflow.com reset password, which has the password reset token in it. And as the attacker, we own dubflow.com, right? This is our malicious server, right? And this means now that if the user clicks on the link, the password reset token will be leaked to us. And as the attacker, we will be able to reset the victim user's password via that leaked password reset token. And to make things worse, the victim user doesn't even necessarily need to click on that email, because what happens is that many inboxes have, and this is a security feature actually, what they do is they automatically click on links and investigate them for malware. And in that scenario, the victim user wouldn't even have to need to click on the link for the password reset token to be leaked to dubflow.com. And if we go back to the code, then the sole reason for this vulnerability lies in line 25, right? So here, the reset link, and we talked about it in the beginning, right? But the reset link is concatenated, is built using the host header, which is under the attacker control. And that's the source of the vulnerability. And to fix this vulnerability, the easiest thing we can do is simply hardcode this. So for example, in our scenario, we want this to be localhost 3000. So we could just hardcode it to localhost 3000, right? However, there is probably a reason why this was dynamic in the first place. And this is, for example, it could be that the application, that they have like a deployment, and they have maybe different versions of the app, QA, dev, production, and so on. And they want to inject the appropriate host header or the appropriate domain into the password reset link dynamically. So they want to make sure that if it's QA, that the reset link is like QA mypage.com, and in production maybe only mypage.com. So they have a reason for that, right? So hard coding it would be great, but in practice it probably doesn't work like that. So what you can do instead is you can either validate the host header against an allow list. So you can have like an if else or a switch case or whatever that checks if this is, I don't know, qa.mypage.com or mypage.com or dev.mypage.com. And if it's not part of this allow list, then you reject the request. That would work great. But the other thing you could do, which is probably a bit more mature, is use an environment variable instead of the host header here. And just dynamically at deployment time inject the appropriate value, because the deployment will probably know if it's a production deployment, a QA deployment, and so on, right? Yeah, that's all I got, I guess. So thanks for watching this walkthrough. Thanks for going through this hosted injection vulnerability with me. And I'd like to add actually that this is a vulnerability that's still very much relevant. And I'm not entirely sure, it must have been either late 2023 or 2024 where I found this exact vulnerability in one of my pen tests. So just like that, a critical vulnerability to reset anyone's password, right? Like a an account takeover, or depending on the infrastructure, either a one-click account takeover if the user needs to click on the password reset link to leak the token, right? Or potentially even a zero-click account takeover if there's some sort of system in place that automatically evaluates links and clicks on them, right? Yeah, just wanted to add that little anecdote. And that's all I got for today. Thanks for watching. Bye bye.